was yesterday. Oh my God. So we have done for our expression of concentrations. Now we go directly to colligative properties. Okay, mga palangga. So, colligative properties in this topic, we need to remember that there are only four. Okay? So for the expression of concentrations, we have at least seven, right? So let's review. First, molarity, formality, normality, molality, parts per million, parts per billion. And the formulation of percentage by mass, percentage by volume. Mole fraction will just follow if you have already the data of these expressions of concentrations. Now we go back to not go back, we need to touch colligative properties. So before going further, we need to know what's the definition of colligative properties. Anybody? So before going further, we need to go back to the studying of matter. As we can remember, we have the phases of matter, state of matter, remember? Changes of matter, okay? And properties of matter. Get the point? So properties of matter, physical and chemical property. Okay, physics of matter, solid, liquid, and gas. Get the point? Classification of matter, sorry, there's also classification of matter. Okay, pure substance and a mixture. Okay, get the point? And changes of matter are physical change and chemical change. So, these colligative properties. Okay? So before touching this, we need to remember that we have physical property. Okay. What I'm trying to emphasize are properties in chemistry. Okay, so that we can really identify the difference and shall we say the distinction. Okay, one over the other, something like that. Okay, physical properties. Okay, or property. And then chemical property, like that. Okay? Chemical property. And then we have also extensive property. Okay? Extrinsic property. And these properties, we need to know the definitions. Okay? Because this will come out to the theories, questions in different examinations. Okay? Related to, of course, general chemistry or science or chemistry. Extrinsic property. Okay, like that. Okay. Okay, mga palangga. Okay, we have also extensive, no. We have intrinsic property and we have intensive property. Okay? Intensive property. And we have also of course our topic is colligative property. Okay? Colligative property. Colligative property. Get the point? Okay. So we need to define physical property, chemical property, extensive and extrinsic property, intrinsic property and intensive property, and colligative property. Okay? So what else? Okay? So ito lang muna. Okay. Physical property is a property of matter. The form and the composition or the chemical composition of matter will not change. We need to say there's no alteration of the form and the phase. Okay? That's physical property. Okay? And then chemical property, there's an alteration of the chemical composition and the forms and phases of matter changes. So this is this chemical property. So extensive and extrinsic property is particularly the same. It depends only for the topic being applied, but normally, generally, it's the same. More extrinsic property, yes, is more on material science study, and extensive property is more on the chemistry study, but basically the same. Okay, this is all about a property of matter that is, shall we say, dependent to the size of the sample or to the system of the sample or the amount of matter present. Okay? Something like that. And the intrinsic and intensive property is the reverse, independent to the sample size, to the size of the system, and to the amount of the matter present. In particular, let us say substances that being considered something like that. And now we go to the qualitative property. Okay, this is now our topic. Okay, so meaning to say this is a property of matter, okay, that is, dependent of the concentration of the solute particles and ions. Take note, particles, okay, and ions, okay, concentration of solute particles and ions. Meaning to say, concentration means the molarity, the molality, like that, blah, 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 so on, so. But for solute, not for the solvent, not for the solution. Solute, okay, particles and ions. Why ions? Because most of the study of colligative properties are dealing with ionic compound that will dissociate ions when introduced into the aqueous solution. You need to say electrolytes, a weak electrolytes, or shall we say a strong electrolyte, that there will be have ionization or dissociation in the aqueous solution. Okay, mga palangga, that's very clear, right? Okay, so let's start now. So what are the four examples of colligative properties? Let's erase this. This is only the recap on the review, right? Okay. What are the four? So let's erase this, mga palangga. Okay. The first colligative properties, again, take note. Only for the concentration of solute particles and ions. And normally here, guys, we refer also to the non-volatile solute, not the volatile. Okay? What do you mean by volatile or non-volatile? So meaning to say, a substance that will not normally vaporize into the atmosphere, meaning non-volatile. Because substances that will have a higher volatility properties are those substances that will easily vaporize to the atmosphere without doing something. You just leave that there and it will vaporize to the atmosphere without applying heat, without applying energy or whatever. Okay, but non-volatile, you cannot vaporize them without doing something. With their internal energy, kinetic energy, temperature, change the pressure, adding an inhibitor, or adding a catalyst, something like that. So it will never vaporize or volatility. Okay, it's very difficult to use the volatility. Volatilize. Volatile. Ay, never mind. Vaporize only. Masakit akong dila. Okay, so like that. Okay, so that is non-volatile solute. Okay, usually again salt, electrolytes, but never to sugar. Okay, and protein or nucleic acid only for salts like that. Okay, and never to sugar, never to organic compound. Usually ionic compounds na talaga siya, guys, ha? Non-volatile. Okay. There's limitation for this, okay? Not for all substances. Get the point. Usually ionic compound. When we say with ionic compound, meaning to say the reaction of metal and non-metal. Okay? Get the point. Non-metal, it will either be a gas. Okay? Like that. Non-metal na siya, diba? Gas, liquid, something like that. Okay? So if molecular compound, both are non-metals, right? Both are gases, something like that. Both ionic compounds, non-metal plus metal. Okay? Get the point? So not a difference. Because the charges are, positive and negative, something like that. So the best example is sodium chloride. Okay? Like that. Okay, go back na sa first. Our first colligative property is, okay, but first, boiling point elevation. Oh my gosh. Boiling point elevation. Nakakaloka. Okay, delta TB. Okay, delta TV. B stands for the boiling point. So by the way, class, what is the boiling point of water? The boiling point of water is 100 degrees Celsius. Okay? So, and then what is the boiling point? Okay, the boiling point is when the vapor pressure or the pressure of the vapor will be equal to the pressure of the surrounding liquid in the container. For example, if I will boil water now, I will take my coffee. So if the liquid pressure will be equal to the pressure of the vapor, and then it will reach 100 degrees Celsius. The vapor pressure is equal to pressure of the vapor. In English, is equal to the pressure of the vapor. Okay? Because and the pressure of the water is another story. Of course, the pressure of the water is not the pressure of the vapor. Get the point? That's why I said it will be equal. Okay? Because they are not the same. The vapor and the water is not the same. Okay? But normally we treat that as vapor pressure. You get the point? In science, we will not say pressure of the vapor. Instead, we will say vapor pressure. Actually, it is only pressure of the vapor. You get the point? Like that. Okay. So we have the boiling point elevation. Here, guys, as I tell you that the colligative property is dependent to the concentration of solute particles or ions. So our expressions here are always solute. Here. Okay? Because we need to identify solute, solvent, and the solution here is very, very particular. Okay, so if you will misinterpret or you cannot understand where's the solute, solvent, and the solution, your answer will be wrong. Okay, so this will be delta TB solute. But take note, solute and solvent has the same first letter, S. So it's very difficult to designate the letter. How can we do this? So we will, and also if we will speak of solute and solvent, the first three letters also is the same, S-O-L. Okay? For solute, S-O-L-U-T-E, so sol, right? For solvent also S-O-L-V-E-N-T, sol also. So what is the best nomenclature or code or subscript for this to identify? So it's gonna be di ba ang hirap? Okay, so we will just understand that these are all solutes, right? Get the point? So, like that only. So, what I'm trying to explain, solute and solvent have the same first three letters, S-O-L. If I will put subscript here, S-O-L, it will be just the same also to solvent. So, in fact, also for solution, S-O-L also is the first three letters for the word solution. So, we don't put subscript anymore here. We will just understand that these colligative properties are solutes, not the solvents or not the solutions. But of course, these solutes and solvents will play an important factor in our formulas. Okay? Like that. So, okay. Boiling point elevation of solute is equals to the boiling point constant. Okay, boiling point constant. You get the point? We will call also this as ebullioscopic constant. Okay? Another term for boiling point constant. Okay? Boiling point constant. Familiar or not? Okay, all we know is the boiling point, right? But we don't know the boiling point constant, right? But in chemistry we have. Okay, the value is 0.51 degrees Celsius over the molality. Okay, the molality is moles of solute, again solute, right? Over kilogram of solvent. Okay, again, the denominator is not solution, kilogram of solvent in molality. That's only the difference. Okay, because the molarity and the normality are all solutions in the denominator. We have to be particular in the, the arrangement of theory, something like that. So it's gonna be the boiling point constant times the molality. Okay. Why I put molality? Because when you if you times this boiling point constant to molality, then the molality will be cancelled. The degree Celsius will remain. That's fine. Okay, times I. I will be our Van Hoff factor. Okay, so it's totally different from the equivalent. Okay, for normality, because in equivalent for normality, you're only considering the OH and the H. But here you have to add on. Okay, the OH and the partner, the H and the partner. Why partner? Okay. For example, if I have HCl, hydrochloric acid, okay, HCl. So if you break that there, here, if you dissociate this, it will become H positive plus chlorine negative. So, in our normality theory, we will only consider the H plus. We will never consider the chloride. So, but this Bantu factor is just the same with the equivalent. But in equivalent in normality, only one will be considered, not the two. But in the Bantu factor, the two. Okay, the hydrogen and the chlorine. So 1 plus 1 is equals to 2. Our I Bantu factor for hydrochloric acid is equal to 2. Another example. Okay, let's master this one so that we can identify really. Okay, for example, I have what else? Charot. So I have limestone, right? Limestone, calcium carbonate. Okay, we have like this. Okay, mga palangga, it will associate into calcium positive 2, and then carbonates, right? Carbonates negative 2. Ganon mga palangga, di ba? Okay. So, balance the chemical equation. Charot. Okay. So, calcium carbonates it become 2. 2 calcium, right? 2 calcium, carbon, oxygen 3 balance. Okay? Now, okay, what is your total metal factor? So it's gonna be 2 plus 2. Okay? You get the point? 2 plus 2 is equals to 4. Okay? 2 for carbonate and 2 for calcium. Something like that. Okay? Dito point mga palangga. Okay. Okay, get the point? Muna siya yung hitabo. Okay? Oh. Another aluminum sulfate like this. Okay? Because we have the I here. During our problem solving, you will never get confused already because it is fast, right? Aluminum sulfate like this. Oh, ganon. So here and here it is. It will become aluminum positive 3. Plus sulfate, negative 2, right? Aluminum 2, ganun-ganun, chupa-chucho, okay? And then sulfur is 3, ganun-ganun, oxygen is 12, so it's gonna be 3, right? So 3 sulfur, oxygen 12, oxygen 12. Okay? Aluminum is how much? So, add this to 3 plus 2 is 5. Okay? 5 siya. Banal factor. Okay? Like that. Okay? Muna siya nitabo. Okay? What else? Ganon. Okay, shall we say potassium chloride, potassium iodide. Alright? Asa yun na kayo? Negative 1 plus 1, 2. Okay, we need to give example that is very easy to detect, right? Okay? Like that. This is our boiling point of the solute. Okay? Boiling point elevation. Boiling point elevation. Ganon. Okay, boiling point elevation. Okay. Now, if you add salt to a solution, what will happen to your molality? This one and like that. What will happen to your molality? Your concentration. Okay? And what will happen also to your boiling point, elevation of your solute? Okay? When you add solute and then, for example, add solute meaning increasing the solute. Okay? Increasing the solute. Okay? Or, meaning to say, increasing the concentration. Basically, when you increase the solute, that is more concentrated. So, meaning, increase the concentration. Okay, your boiling point elevation of your solute, which is here, will be going down. Okay, like this. Going down. Okay, ganon. Or the boiling point elevation itself going down. Meaning to say, if we speak about boiling point elevation, that refers to solute, not solvent and not solution. Okay? And then your molality will also go up, of course, because solute is molality or concentration. Okay? Like that. Okay? Like that concentration, molarity. Or meaning to say, if you increase the number of moles, increase the number of moles, increase the numbers of solute, increase of the concentration, then your boiling point elevation of solute will decrease or will be lowered, something like that. And that's the first boiling point elevation. And now secondly, we have the boiling, freezing point. Okay? Freezing point depression. Okay. For example, mga palangga, I will get the ice inside the refrigerator, and then if I will spread salt on the ice, it will melt easily. Okay? Get the point? So the same as also if we apply in our world, in our planet Earth, then if we have ice too much cold, if we put salts on that, salts, a lot of salts, right? And then it will lowers the freezing point like that. Okay, so it will not become more cold anymore. Okay, you get the point like that. So that is freezing point depression. Okay, this is T delta T F freezing point of solute. Okay, but before going this, I forgot to tell you that the solution, boiling point of the solution. See, if I have the water and then I don't add yet the coffee powder, right? Our coffee powder is actually the solute, right? But if I don't add that one, and then I put also the coffee powder later, something like that, so that will be our solution already. So, boiling point of the solution is equal to the boiling point of the solvent, okay, which is normally the water, okay, plus the boiling point of your solute. Okay, guys, this your boiling point of your solute. This is what we call the boiling point elevation, not for the solvent, not for the solution. That's why when you manipulate these things, if the problem will ask for what is the boiling point elevation of solvent, you can get exactly what is the value. And the boiling point of the solution, you can exactly get also what the value. You get the point? Since we know the boiling point of solvent, which is water, which is 100 degrees Celsius always, then you have to add this boiling point of solute elevation always, like that. Okay? Then if the problem will give the boiling point of the solution, then you can automatically get also the boiling point of the solvent, like this. Play around math already if you have the values. Sa math na ta magdaog ana. Okay, because it is purely addition. Right? See? Boiling point of solution is equal to the boiling point of solvent plus the boiling point of solute, which is our boiling point elevation. Ganon. So, our boiling point of the solvent is equal to the boiling point of the solution minus the boiling point of the solvent. Okay? Kita po mga palangga. Muna siya may tabo. Charot! Okay? Okay, pwede sabihin mo na naman siya, solvent, baliho na po din mo siya. Basta kayo na siya guys, you have to take note the math. Okay? Subtraction and addition only. Okay? Correct ba? Yes. Okay. Freezing point depression, mga palangga. Okay. This is negative key F. Okay, so freezing key F is a freezing point constant equal to negative 1.86 Celsius. Ganon. And you have to memorize this, guys. There are two only, very easy to memorize, right? For water only. Other will be on the inorganic liquids, blah blah blah, so and so. But you have to look at the table in the books or different kinds of books, and normally it will be given in the problem. But if water only solution, it is understood that the students will memorize that already. Never, the problems will not put already the values. Okay? Just to tell you the truth. Okay, like that. So it is understood to be negative 1.86 Celsius over molality for the freezing point elevation constant. Okay? No, sorry, depression. Okay, freezing point depression constant. Let's always think this ang freezing point lowering lowering siya. Okay, because it will not be forever solid like the ice. Time will come, it will really melt. That's why this depression or lowering. Okay? You get the point? Uh, Alam nga mga ice na yung bato. So, uh, time will come, it will really melt. Okay. Nakaloka. Okay, times molality. Okay? Times the I, the Van Hoff factor. Okay? Like that. O, ano siya, guys. So, if I have the freezing point of the solution is equal to the freezing point of the solvent, okay, minus. Okay? But you don't have to minus yet because we need to add because that's solution. Later na kung mag-carry na taong sign tuba chuchu. Okay, sign. Negative, positive, like that. When you substitute that there, it will become negative. So let's just follow first the standard of solution in English. Solvent plus solute, like that. Okay, temperature of the, okay, freezing point of solute, solvent, okay, and plus freezing point elevation of solute. Okay. Okay. Depression. Okay. So when you say about freezing point depression, solute, not the solvent. Okay. Solvent. Okay. So when you get the solvent, okay, you can solve that. Okay. You get the point mga palangga, and then you will say, for solvent is equal to solution. Okay, freezing point of solution minus the freezing point of the solute. Freezing point depression of the solute, like that. Okay? Again, math. Okay, plus subtraction, plus subtraction. Okay? You get the point. So let's go now to the theory relationships of the quantities. If you add more solute or non-volatile solute, what will happen to your freezing point depression? Your freezing point depression of your solute, right? So increasing the number of solute or more solutes, or again, adding more number of moles, is this the same? Or increasing the molality or concentration? Okay, it will lower down your freezing point of depression. Look at the F of the solute, like this. Okay? We need to know this because somewhere along the way in our problem solving, we can easily check that our answer is correct. Maybe we get a very high freezing point depression and that is wrong. Because we need to compare later on our answers. The freezing point of the solution versus the freezing point of the solvent, like that, so and so. Okay, so if that is not really matching to the theory, then that is wrong. Okay, even though how hard you try for the math, for the solution. Okay, you feel that your solution is already perfectly done correct, but it's very, very low, so something wrong. Like that, okay? So number 3, okay mga palangga. This is interesting, number 3, really. This will be used in the Rayleigh law, okay, in physical chemistry. Okay, this is the basic. That's why we need to understand this. Okay, so number 3 is the vapor pressure lowering of the solution. Okay, vapor pressure lowering of the solution. Guys, in this topic, we don't need to put letter V for the vapor pressure. We don't need to put the underline above the letter P, right? Because sometimes we need to put underline above letter P, that is partial. But we need also to put a small circle at the top of letter P, that is vapor pressure. If we don't put any nomenclature or any symbol or anything chuba-chuchu, that is only vapor pressure or pressure. Kakaloka. You get the point? Okay, but just memorize that in the colligative property, we are referring to vapor pressure, not the pressure regular. Meaning pressure regular, we don't state if it is a vapor, if it is a liquid, if it is a gas. Meaning to say, general pressure. Okay, the pressure of a person, the pressure of the liquid, the pressure of the gas. But here really vapor pressure because we are dealing with non-volatile solute or solutes. Okay, from the definition of our colligative property, right? Depends on the concentration of solute particles or ions. Okay, So our vapor pressure is just letter P. Okay? We don't put anything circle like that. Okay, but in another topic in chemistry, we need to emphasize that also, especially the Dalton's law of partial pressure and the Pascal's law of pressure. But here you don't need. Okay, so we have the vapor pressure of the solution. So P so SOLN because to make it unique. Okay, vapor pressure of the solution is equals to the mole fraction of solvent. Okay, mga palangga. Okay, get the point. Times the vapor pressure of the solvent. Okay, take note mga palangga. We don't touch here solute. Okay? We don't touch here solute. Okay. Our definition here, the solution only and the solvent. Take note, most of the students, examiners, including me before, 20 years ago in my chemical engineering, sometimes I may confuse with the vapor pressure of the solute here somewhere along the way. That's why we need to memorize what's in there, in that vapor pressure lowering of the solution. There is no solute there. It's always solvent is being asked. That's why we need to compute also the solute because it's related to the mole fraction. Okay? It will be contributed to the mole fraction. That's why we need also to solve the solute particles or whatever like that. Okay? It's gonna be like that. Mole fraction of solvent times vapor pressure of solvent. Since we know the mole fraction of solvent is okay, N solvent, mole fraction of solvent, okay, N solvent, mole of solvent, okay, moles, over moles of solvent plus moles of solute. Okay, see, it's in there that the mole N solute will be obtained. Okay, before you can put in the X solvent. Because in the mole fraction of solvent, we need to know the moles of solute. Okay? So there's no escape. We need also to identify the characteristic of the solute. Okay? Ganon siya, chuba. That's the vapor pressure of solvent. Okay? Ganon. Okay, mga palangga. Okay. Now take this relationship if you add the solute, non-volatile solute. So if you add the non-volatile solute, okay, more solute, more concentrations, more molarity, your vapor pressure will be lower. That's why it's called vapor pressure lowering of the solution. And at this time, this is not the solute. It is the solution that will be lower the vapor pressure. It's not the same with the boiling point elevation and freezing point depression that talks about solute in the formula. You get the point? This is only for the solutions. Vapor pressure lowering. Really? Then to slow pala is vapor pressure lowering if we add a non-volatile solute. Ganon. So theory na yan. Okay, number 4. Okay. Number 4 mga palangga. Okay, what do you think for this mga palangga? Number 4. So this is the osmotic pressure. Take note, this is very strange and unusual because in our trigonometry, do you remember the pi? For example, the circumference of a circle is 2 pi r. Like that, like a chuba-chu-chu. Like the surface area of, let's see, not surface area, okay, lateral area of pipe opening, which is pi d squared over 4, right? Pi d squared over 4, but in terms of radius, that's only pi r squared, something like that, if you can still remember that one, right? And then, pi is there. So what is the value of pi in our math? That is 3.1416. But take note, the pi symbol is also our symbol in osmotic pressure. That is pi. But it is not 3.1416. It is only used as a symbol, stands for osmotic pressure. You get the point, mga palangga? Ganon. So it's gonna be molarity times the universal gas constant times the T temperature times the I Van factor. Okay? Like that. You get the point mga palangga? Muna siya yung hitabo. Nakalaga. Okay? So take note guys, in our vapor pressure solution lowering, there's no Van factor, right? Only in the boiling point elevation, freezing point depression, and our osmotic pressure. And R is our universal constant. So ganito, 0.08 to 0.5 liter atmosphere mole Kelvin, or we can also use 8.314 joules per mole Kelvin. Or you can use any other value of universal gas constant, just derive it by using the PV in RT at standard temperature and pressure at 0 degrees Celsius to 98 Kelvin, and also at 1 atmosphere. Okay? Like that. At sea level. That's the standard, right? At sea level, at 1 atmosphere, and 298 Kelvin. Oh my gosh. Okay, now, if we add more solute, what will happen for your osmotic pressure? More solute, more concentration, more number of moles, then your osmotic pressure, okay, what will happen? Will also increase. The same as the boiling point elevation. Okay, so you need to memorize the relationship. But anyhow, if you have the formula, you can extract the proportionality, inversely proportional, directly proportional. In that, you can understand what will happen to the other one if you increase the other one like that. There's no such thing as you should memorize everything. But my point is so that you will never write anymore the formula. Because sometimes you forget the formula, then you forget also what's the relationship, right? For example, me, I memorized already was the relationship between the pressure and the velocity, the pressure and the diameter, the velocity and the pressure. So even though I forgot the formula, I still remember their relationship. For example, if the diameter is very small, what will happen to the pressure? Like that. The pressure will increase if the velocity is very high, very low. Like that. Okay, you take note the relationship. Okay? For example, if the airplane is very fast, okay, what will happen to the pressure? Okay? Like that, when it's still in the ground, and then it will fly. Okay? Too much velocity, what will happen to the pressure? Ang ganon. So you can also tell, the pressure pala is higher if it is too much high. Example only. Okay? Like that. You get the point? Like that. It will go to the sky like a jet plane. You can determine the relationship between the velocity, the pressure, the height, like that. Okay? But normally, there's a kinetic energy. We can determine also the formula of kinetic energy and potential energy, right? No need to worry because it's being considered in the Bernoulli theory, right? Okay. But since sometimes we cannot memorize everything about Bernoulli theory, okay, but we need to understand the proportionality. Okay, going back to the colligative, it's very easy now, and we need to go to the problem solving. Okay, guys, I'm talking very fast. I'm running out of time. So if you like this discussion, you can comment, like, and share, and you can subscribe my YT channel if you want also, and click the bell notification for some newest updates that I am a senior channel voice. Bye bye, and that's for all theories, concepts, and principles of colligative properties. Bye bye. See you later for the problem solving.